Yung anak ko nga, parang sinisigurawan na ako. Ilan ka galit? Oo, pero hindi. Meron ang halit, restoration. Dahil hindi niya ako kaya. Sabi ko, anak, kasi ko, kasi naalala ko yung first translation. Parang nag-issue italungan dito sa diba? Dalawa yung chance. Nag-research natin. Kaya tayo research.
Ayan, boss.
Sige, sige.
Alam niya. Opo.
Ay.
Sino siya? Kanina, lunch mo pala. Ha? Late na. 12:30 na. Spot mo?
Okay, are we clear? Is the sound clear? So let's start. Shout out daw kay John Lloyd Narito. Shout out. Siguro artista yan. Okay, so let us get back to our live stream. We are here live at Taguig City University. So let's begin with this document, which is one of our reference books. So there are several main topics in our utility 2 course, and number 1 main topic is plumbing and sanitary. So we are going to discuss. So let us go to this one, plumbing system. As you can see in your screen. So plumbing system, we will take a look at the home plumbing system, water supply piping, drain, waste, vent piping, plumbing vents, plumbing traps, and plumbing appliances and fixture. So that is what page 'So I think this is the
Nagpas na rin siya. Hindi na 100 kapag so, hindi na 100 points siya. Hindi ka ba na? Basta, hindi na 100 points siya. Hindi ka ba na?
Where's the plumbing system? Plumbing system. So, okay. Components. Emergency escape.
Ready to work na.
Plumbing system is about here. About here.
Okay ba? Meron makakala pa naman dito. Tsaka ka na. Slide siya niya. Hindi ka na lang siya. Ako.
So after this, we have the plumbing. No? That is a plumbing system. Okay. So let's make it a little bit bigger. Okay. And here we go. So plumbing projects are one of the most important. So just like what I am always saying, I always observe that our building official, at the minimum, at the very least, will approve an engineering plan for building permit and for occupancy permit with only what? Civil, architectural plan, plumbing plan, and electrical plan. 4. Only those 4. Although we already learned that there are about 8 to 9 professionals that would sign an engineering permit, but minimum is 4. So one of which is plumbing system. Okay, because under plumbing we have the pipings for what? For sanitary. For sanitary ducts. Okay. So that's why it's very important, and mostly we are what, for convenience or for economy, we are hiring foreman, we are hiring carpenter to do the job. But the most important thing in our course is how these people that engage in plumbing system, engage in plumbing works, engage in installation or probably design, think about their plumbing system, how they do it, how they think about planning the direction of pipe, how they install it, so that we can have an insight. Okay, so finally, we will in detail look into the specific requirements. So let's start with the discussion of the whole system. So what we call the home plumbing system. So then next we will take a look at the water supply, piping, then DWV. DWV is the word for drain, waste, and vent. I will define it later in more detail so that there is no confusion. Plumbing vents, plumbing traps, and plumbing appliances and fixtures. Again, let us introduce some of the definitions. Okay, important definition. Okay, so let's start with some branch vent and branch drain. What do you mean by branch drain and branch vent? So branch drain is a drainage pipe that takes soil and waste from fixture drains to a stop or to a building drain. Okay. So therefore, we can conclude that a branch drain is different from building drain. Okay. A branch drain, in fact, is a piping that takes soil. What do you mean by soil? And waste. What do you mean by waste? Soil meaning it involves human waste. Okay? It involves human waste, and because human waste will go back to become soil later on. So that is the terminology being used, no? Soil. Okay? And also soil because it involves dust, and also the soil, for example, the dirt, for example, coming out from outside, you are going inside your home and you will clean yourself, and because of the dirt, dust, and actual soil from your boots, from your shoes. Okay, you will clean up your shoes, you will clean up your slippers, you will clean up your clothes. It may have some actual soil in it as a dirt, no? So that's why we call all those things, meaning soil, those are the waste, including the human waste, okay, that involves solid. Why solid? That is what we mean by soil in this context. Okay. What about waste? Soil and waste. Waste in this context involves both solid and liquid form of waste. Okay. So liquid form, that means those are human waste that is in liquid form. That is our urine. Okay, urine. Not only urine, so there are liquid waste from kitchen. Okay, from kitchen, and this pipe which is connected from the fixture drain to a stop or to the building drain. Take note of that. So a branch drain can only be connected to a stop or building drain. What about branch vent? A branch vent connects other vents, usually individual and common vents, to a vent stop or stop vent. Okay? Vent stop and stop vents are different from one another. Okay? I will have an explanation of that later with pictures so that there is no further confusion. So just take it as it is right now. We will explain it more thoroughly later. What about building drain? So it was mentioned, building drain is mentioned. It is connected to branch, okay? Branch drain. So the building drain is usually the lowest horizontal drain pipe. Take note. It is easy to understand because this is the lowest horizontally connected drain pipe. in the building and collects material from branches and stocks. Okay, branches and stocks. Okay, so a branch can be connected to a stock and to or to the building drain. Okay, so that is what we mean by branch. Okay, and the building drain extends to 30 feet beyond foundation. Okay, 30 feet. Okay, 30 inches rather. 30 inches, meaning going, okay, going beyond the foundation where it connects with the building sewer. Okay, so building drain is different from building sewer. Okay, a building with fixture below the building drain, such as in basement, has a building subdrain. Okay, material in a subdrain must be pumped up to the building drain. Okay, now, what do you mean by building sewer? So, building sewer is usually refers to the pipes beginning at the building drain, right? Beginning here, so those pipes that is connected to building drain, right? Starting from that point and will end at the public sewer or septic tank. Either at the public sewer or septic tank. So that is very short amount of pipe, no? So it connects the building drain to the septic tank. Okay, that is what we call building sewer. And what do you mean by fixture? It is fixtures are any device that connects to water supply, note, water supply pipes, and connects to plumbing waste pipes. Not only water supply pipe, but also plumbing waste pipes. Okay? So, what do you mean again by plumbing waste pipes? Okay? Waste could either be solid or liquid. It is a mixture. When we say soil, that is only solid. Okay? When we say waste, that involves a mixture of liquid and solid. Okay? So those pipes that allows plumbing waste. Okay? So that is what we call plumbing waste pipes. So those devices that are connected to this type of pipes are what we call fixture. Fixture include toilet. So what do we mean by toilet? That is what we mean toilet bowl. Toilet bowl is what we say toilet. And actually, technically, that is what we call water closet. Okay? Technical term for toilet bowl is water closet. Okay? It could also be sink or lavatories. Okay? Involves kitchen and laundry sinks, bathtubs and showers. Those are what we mean by fixture. Okay? Sink, bathtub, shower, right? So water closets. Okay? So those are our fixture. Okay, so let us jump to other type of. So stock. What do you mean by stock? Okay, this book also defines soil. Material in the plumbing drainage system that contains urine or fecal matter. What do you mean by fecal? Fecal means the human waste. Okay? The solid part of human waste. That is what we mean by fecal material. Not only human waste. For example, animal waste. Okay? So that is what we mean by fecal. So, animal or human waste. Okay. So stack, what do you mean by stack? A stack is the vertical. Take note, vertical. The word vertical. So if the pipe is vertical, okay, and it is a plumbing drain or waste pipe that extends one or more stories, stack collects waste material from horizontal drainage pipe and conducts it to the building drain or other horizontal drain. So what do you mean by horizontal drainage pipe? This is what we call branch. Okay? Okay? So stack is vertical. Branch is horizontal. Okay? So let us continue. Traps. What do you mean by traps? Traps are the S or P shaped pipes in a fixture drain. Okay? For example, laboratory. Always there is a P or S type pipe that is connected to a laboratory fixture. Their purpose is to prevent sewer gas from coming up through the drain opening, from coming back up through the drain opening. What do you mean by that? Because if the sewer gas comes up back to the drain opening, we will smell very, very bad. For example, after taking what? CR, no? Toilet. After somebody use the CR, for example, urinating and what? We will expect what? Bad smell. So that is bad smelling, that foul smell would be prevented if we have what? P or shape traps. P or S shape traps. Okay? That is what we mean by traps. Okay? It traps the gas, the foul smelling gas. Okay? So, where did it go? It will go to the waste system down up to the end of the waste pipe. So meaning to the sanitary vault. Okay, either public or public sanitary vault or the like. Okay. So let's go to the next. Okay. Water pressure versus water flow. Water flow and water pressure are often confused with one another. Water flow is amount of water you can get from a full water pipe. Water flow is the amount of water you can get from a full water pipe. Water pressure is the amount of force that the water exerts on the walls of a full water pipe. Once a pipe is full of water, a water pressure increase will not increase the water flow in the pipe. In fact, a water pressure increase within a certain amount will cause the pipe to burst. Okay? So this is the difference. Okay? Okay, so there are water tanks that burst. There are pipes that burst, but the pipe is stronger than tank. That's why the tank will burst first. Okay. There are instances. There are instances in our country that there are injuries. So many people injured, getting injured. There are even fatalities sometimes. Okay. When some incident of tank bursting, there are I think several instances of this. As I can remember, in parts of Quezon City and parts of Bulacan province. Okay. there are deadly bursting of water tanks. The ideal water pressure is between, take note, memorize this, okay, 40 to 60 psi. That is the ideal. Okay, no need to go over that. Take note, 60 psi, 40 psi can carry a lot of people. This magnitude of pressure can carry a lot of people. Take note, the jeepney tire pressure is about 60 or 40 to 60. The jeepney tire pressure is about 40 to 60, and jeepney bus is about 60 psi. Take note, a bus could carry about 60 to 70, and if the bus passengers are standing capacity about 80 person, okay, could be carried by what, 60 psi. So imagine that. Water flow is primarily a function of size, type, and installation of water supply. So we are using water pressure, in order for the water to flow smoothly. Okay, particularly going up to the high lands. Okay, or they are sometimes higher than the source of water. So if the source of water is lower elevation than the house or the water consumer, definitely we need water pressure. So sometimes if the natural water pressure is not enough, we may need additional pumps, okay, additional water pumps for that purpose. Okay, so pumps are used for those type of areas. Okay, so that is under the responsibility of plumbing, master plumber. In our country, the person responsible and authorized, licensed by the government to work in that area is what we call master plumber. Okay. Take note again, if you graduate as a civil engineering student, you can take the board exam for master plumber. So there are disciplines that can take board exam for master plumber, like graduate of mechanical engineering, civil engineering, chemical engineering, architecture. So those are engineering graduates that can take master plumber board exam directly. So meaning directly, you don't need to have experience to take the board exam. That is what I mean by directly. Okay. So minimum and maximum pressure for dwelling. What do we mean by dwelling? We mean residential area. For residential area, we only need 40 psi minimum. 40 psi static water pressure. The minimum pressure applies to both public and private. So water supplies pressures as close as possible to where the water supply enters the building. So that is how we measure the pressure of water. Okay. Do not exceed 80. Okay. So really, it is about 40 to 80 because 80 is becoming dangerous. This supply of 80 pesa is nearing the dangerous level. Okay, bursting. Okay, install an approved pressure reducing valve. That's why we need a pressure reducing valve. So because to avoid the danger of bursting. Okay, that is the countermeasure in order to prevent bursting. Okay, so we need pressure reducing valve if we know that the pressure is nearing 80. So 40 to 60, maybe that is the normal. Okay, so install that if the static pressure exceeds the maximum. Okay, so this is the maximum, this is the minimum. Okay, measure the water pressure to the point where the supply enters the building as close as possible. Okay, so as the pipe enters the premises, so we need what? Pressure gauge, so that we can measure the water pressure. Actually, we don't need the measurement. We just need what? A provision for measurement, so that we can just what? Put the pressure gauge whenever we want to measure the pressure, and then take it off whenever we don't need it. So there is a provision. So maybe a Y what connector is okay. No? Minimum flow rate at fixture is also needed. Okay? Minimum flow rates. So let's take a look at minimum and maximum. Okay? So minimum and maximum for fixture. Okay? So you can what? You can memorize one or two of these. Bathtub, you don't need to memorize because it is not always used. Bidet, okay? Bidet, you don't need to memorize because it is not common to our country. Bidet is common to Europe. Even in United States or in Japan, it is not common. But European use bidet. Okay? Dishwasher, not very common in our country. Laundry tub, of course, laundry is common, but tub is not in our country. Lavatory is a common one in our country, so you can memorize this. So we need what? 0.8. What do we mean by GPM? GPM means gallon per minute. Okay, that is the minimum. 0.8 gallons per minute for lavatory. So the highest is for what? The highest is hose bib. Second is bathtub. So what is hose bib? Hose bib is the provision for connecting the what? Hose. Okay. So hose bib, that is what? That is a fixture. That is a that looks like a faucet, no? That looks like a faucet. So that is hose bib. So it needs what? 5 gallons per minute. Okay. So hose, you can what? Use. You can even use this for what? Initial fire fighting. Okay. So if there's a fire, you can use this hose. And for what? Cleaning the car. So near the garage. Okay. You can use the USB. So it has pressure, so that it will what? It will spray water. So that is what we mean by this hose bib. Shower, we only need about 2.5 gallons per minute. Take note, lavatory and sink are the least. So sink, okay. For example, kitchen sink. That is one type of sink. So that is only 1.75 gallons per minute. Okay. The lavatory, again, is 0.8. Okay. What about maximum? Okay. Maximum. So, lavatory, 2.2 gallons per minute at 60 psi. Shower head. So, this is shower. minimum 2.5. Okay, maximum 2.5 at 80 PSI. Okay, 80 PSI maximum. So over that, it will become dangerous. Okay, 2.5. That is maximum. So 2.5 for shower. Okay, sink. This is a minimum of 1.75 but maximum 2.2 gallons per minute at 60 PSI. We are talking of maximum. So therefore, it is a safe bet to use 60 PSI or less. So about 40, really about 40 to 60. That is the safe pressure. Okay. Okay, what about the next one? Common water distribution pipes. So install water service pipe that has a working pressure rating of at least 160 PSI. Okay, so I may need to open ah, what do you mean by water distribution pipes? Inside the premises. Okay, so water service pipe has working pressure rating of at least 160 PSI at 73 degrees Fahrenheit. Okay, 73 is about 20 degrees Celsius, 21, 22, something like that, or the highest available pressure, whichever is greater. Common water distribution pipe materials for residential connection. Okay, so table 3.1. So this is the table 3.1. Okay, common material for what? The distribution piping. PVC. Okay, CPVC meaning what? It is a plastic pipe. Okay, copper and the copper alloy pipe and tubings. Also another type of plastic pipe, the PE pipe, okay, polyethylene type of pipe. Okay, so we can use that, but under slab and concrete. Okay, so plastic can be used under the slab and concrete. Okay, copper tubing, we need the type M of copper. So mostly we need those pipings under the concrete slab for what? Aesthetic. Okay, and also for what? Because it is not a beauty if you can see the pipings lying around, lying on the hanging on the ceiling. So hanging pipes, they are not a beauty to see. Okay, that's why it's better for them to be under the concrete. But the concrete slab must be strong enough to hold this type of pipes. Okay, because there are what? Pipes that are about 4 inches, usually 4 inches, very usual, very common in the construction, and the thickness of slab is about it could be 100, the slab could be 150, it could be 200 or less than 200 mm. So if you put a pipe of 100 mm to a 150 mm slab, therefore it may not be able to hold the pipe, and even it will what? It will break naturally, meaning the concrete will be broken naturally. Okay, so water supply pipes, okay, material sometimes PVC, sometimes polyethylene, blue for cold and red for hot. So there is a color coding for water supply pipes. So not only the waste pipe, plumbing also involves in water supply, okay? Meaning clean, portable water supply in a building. Okay, so blue and red. That is usual. Even in the dispenser, you can see the water dispenser. Color blue is for cold and red for hot. Okay, that is the usual color coding. So I am looking for the for the last 3 to 5 minutes of our discussion. I am looking for the what the pictures. I'm looking for the pictures. I need the picture to show to you the okay. Uh, okay. So let's go to this. So let us first stop this stream and open another stream for the pictures. Okay, so